Suppose we're given the series n over n plus 1 times 1/2 to the n. How would we deal with this series? Now, it's a little bit more complicated. Maybe you could use a limit comparison test. But let's think of this first term here. We have n over n plus 1. If I use n equals 1, I'd get 1/2. If I use n equals 2, I'd get 2/3. n equals 3 would be 3/4, and so on and so on. In fact, if you look at this, this sequence of numbers is always going to be less than 1. And this comes from the fact that n is always less than n plus 1, which should be true. So you know this value right here is always less than 1. So this whole series should be less than the series of n equals 1 to infinity of 1/2 to the n, right? Because each term here is going to be 1/2 to the n times something smaller than 1, where this is just 1/2 to the n times 1. Now this series is in a geometric series. Remember, ar to the n, where our r value is less than 1 because r is equal to 1/2. Since r is less than 1, the absolute value of r, of course, since the absolute value of r is less than 1, we know that this series here converges. And if this series converges, and this series is always less than this series, and both of the terms are positive, then by the comparison test, direct comparison, we know that this series converges. Now, an important thing to note is both of these series are always greater than 0, these Bn values. We'll soon be getting into alternating series where we have negative values, and we can't use our comparison tests in our alternating series because we have values that are negative, and that could cause some problems.